Hello everyone. Today we have to discuss about linear regression analysis. Myself, Dr. S.T. Patil. Agenda: calculate and interpret the simple correlation between the two variables. Determine whether the correlation is significant or not. Calculate and interpret the simple linear regression equation for a set of data. Understand the assumptions behind the regression analysis. Determine whether a linear regression model is there, it is significant or not. This is the agenda. If suppose we have to consider one example, we have to calculate this one tree height and trunk diameter. If any forest is there, in this one there are so many trees are there. By calculating, by measuring only trunk diameter, we can find out the tree height. Such type of model we have to build. Here trunk diameter indicated by this one x parameter, x variable. Tree height is there, that can be indicated by y variable. Here any values are there, 8 samples are given. We have to find out the, we have to first build, we have to first test it whether this data is there, whatever given data is there, samples are there. Here 8 samples are given, 1, 2, 3, 4, 5, 6, 7, 8. These samples are suitable or not. For model building, we have to test it, and then we have to calculate, we have to build the model, linear regression model. And whenever we are considering any trunk diameter, it may be apart from this one, other than any value is there, it may be 15, 20, like that one. For that one, we have to find out the tree height. If such type of examples are there, at that time we have to use the linear regression algorithm. Before this one, we have to understand the scatter plot and what is correlation. Scatter plot, what is this one? It is also called as scatter diagram. It is used to show the relationship between two variables. Two variables are there, x and y, trunk diameter and tree height. What type of relation is there, that can be indicated by scatter diagram. Correlation analysis is used to measure the strength of the association linear relationship between two variables. What type of correlation is there, whether weak is there, strong is there, that can be calculated using correlation. Here scatter plot examples we have to see here. There are two types of scatter plots. Linear relationship is there. Curvilinear means what? Non-linear relationship is there. If suppose two variables you have to consider x and y, trunk diameter and tree height. Whatever given samples are there, you have to plot here. Whatever the pattern is there, here we can draw the line like this one. It is straight line, linear line we have to draw here. In another case, you have to see these are the samples. Here we can draw the line like this one. If such type of the scattered plots are there, these are called a linear relationship. Another type is their curvilinear relationship or non-linear relationship. Here, the data samples are there, feature vectors are there. Those can be plotted in between x and y. Here, pattern is like this one. We can draw the line, curvilinear type of line we have to draw. Here in this one, if suppose the data points are represented like this one, then we can draw the line like this one. Means what? There are basically two types of relationships are there, linear relationships and curvilinear relationship. Linear relationship means what? The straight line draw, we can draw the straight line. Curvilinear means what? Curvature type of line we have to draw. Another type of uh, this one, based on this one, strong and weak, there are two types of scatter plots are there, strong relationship and weak relationship. This one is the type of correlation. Here if data points are there, these are near to each other, the distance between the two data points are near to each other, less distance is there, then we can call it as a strong relationship. If suppose the distance between the two data points here is more, then we can call it as a weak relationship. There are four diagrams are there. These two Upper side left, upper side is there, that is the strong one. Below this one is also strong one because data points are near to each other. Here you can see weak relationship is there. Weak relationship means what? Distance between the two samples, two data points, two feature vectors is more. Like this one. How to calculate this one distance between the two data points? We can use this one, whatever the Euclidean distance we can use. Euclidean distance. Scatter plot, another example is also there, that is no relationship is there. If the data points are spread across this one quadrant, first quadrant you can consider, if all the values are positive, x is trunk diameter, y is the tree height. In this one, we cannot draw any type of line. There is no pattern like linear, increasing, decreasing, strong, or weak like that one. Here in below diagram, here samples are like this one. Here we can draw the line. Here we can draw the line, but whatever the all the values of x, only one y value is there. We can draw the line like this one. Then such type of the diagrams are there, scatter plots are there. These are called as no relationship. If such type of data is there at that time, even though algorithms are there, models are there, those are superior, then also we cannot get whatever the accurate results. That's why first you have to test it whether that data is suitable for model building and testing purpose. If it is yes, then and then only you can go further. Regression analysis. What is this regression analysis? Actually, it is used to predict the value of the dependent variable. If one value is known, dependent variable, uh, independent value variable is there. Based on that one, we have to find out. Means what? Predict the value of the dependent variable based on the value of the at least one independent variable. If x is known, y can be calculated. If y is known, x can be calculated. Vice versa, it is possible in this one. What is dependent variable? Dependent variable means what? Y is there. Tree height is there, that is dependent on the trunk diameter. The variable we wish to explain. Independent variable means what? X is there. The variable used to explain the dependent variable. Means what? We can easily measure trunk diameter. Based on that one, we can calculate the height of the tree. X is known, y can be calculated. That's why y is the dependent variable that depends on the x. X is the independent variable. Simple linear regression model we have to uh, see here. Only one independent variable is there. If suppose relationship between x and y is there, described by linear function, it is just like y equal to mx plus c only. Mx plus c only, it is linear, it is straight line equation. Y equal to beta 0 plus beta 1 x is there. Here these notations are used, beta 0 and beta 1. X is independent variable, y is dependent variable, beta 0 and beta 1. We will see what are these things are there. Changes in y are assumed to be caused by changes in x. If x is changed, trunk diameter is changed, then tree height will change. That is based on these two parameters, beta 0 and beta 1. Here correlation coefficient, first we have to test it whether given data is there, samples are there, those are correct or not. The population correlation coefficient rho measures the strength of the association between the two variables. How much strength is there? What type of association is there? That can be calculated. Population means what? Whenever all the data points are there in the data set are considered, then we can call it as a population. If suppose any data set you have to take it from UCI machine learning repository or Kaggle, for that particular data set, if thousands of data are there, all the data points are considered, then that is nothing but population correlation coefficient. Another one is there, that is sample correlation coefficient is also there. It is represented by small r, is an estimate of rho only. and used to measure the strength of the linear relationship between the whatever the sample observations are there. If the data set consists of thousands of samples or thousands of the data points are there, out of those you can use this one, 100, 500, like that one. Then the same thing you can do it, but it is called as sample correlation coefficient. Population correlation coefficient is there, that can be represented by rho. Sample correlation coefficient is there, that can be represented by R. What are the features of this one, rho and R? Whatever range is there, range of this one between -1 and 1 only. After calculation of rho, or you can calculate for sample, or you can calculate for that one if values are near to zero, then we can call it as a the value is closer to zero, then the weaker linear relationship is there. If the value is near to -1 and +1, either it may be minus or plus, but it is near to this one, rho value is there, that is near to -1 or near to +1, then we can call it as a strong relationship is there. If it is near to +1, then we can call it as a stronger positive linear relationship. If the value is near to -1, then we can call it as a closer to -1, the stronger the negative linear relationship. On both sides, it is stronger only. For any model building purpose, the rho and R values should be near to -1 or +1. Generally, what we are doing here, whatever the 0 is there, from 0 to -0.5 and 0 to +0.5, this much range is there, it is neglected. If the row values are coming in between this one, then we are neglecting that data, we are rejecting that data. Again, another type of samples can be taken. If the value is more than zero point 0.5 up to +1, or if the value is -1, minus zero point 0.5 to -1 is there, then that is stronger one. Such type of data are selected, samples are selected for model building. Then correlation coefficient we have to find out. Sample correlation coefficient can be calculated based on this formula. Why this correlation coefficient is there, relation is there, that we have to find out whether that data is suitable for model building or not. That we have to, for further analysis, we have to calculate this one, correlation coefficient. Based on this correlation coefficient, the data is tested whether it is used for further analysis or not. The formula for this one, sample correlation coefficient, is that R equal to, it is sample 1, that's why small r is used. Here, n summation of xy, n is number of data points taken here. X is the dependent variable, y is the independent variable. X is independent variable, y is the dependent variable, minus summation of x into summation of y you have to take, and divided by under root of n. N means what? Data samples. Here whole x square you have to take, summation of x square you have to take, minus summation of x whole square you have to take, into n summation of y square minus summation of y whole square you have to take. This is the formula for what? Correlation coefficient. Here R is sample correlation coefficient, n is sample size, x is the value of the independent variable, and y is the value of the dependent variable. This formula we have to use. For what purpose? Correlation coefficient calculation purpose. For testing the data, data samples are there, those are suitable or not. Here, if suppose to calculate this one, what we are doing here, whatever the x and y values are given, these two columns, trunk diameter and tree height. Here 1, 2, 3, 4, 5, 6, 7, 8 samples are there, means what? N equal to 8. Next, further, these values are required, you have to extend the table. You have to take next column, x into y square is required, x square is required. Summations are also required, no, in the formula. Summation of y, summation of x, summation of x square, summation of y square, summation of x square. These are required. For this one, you have to calculate this table. This one is simple statistic. You have to multiply and you have to take the square. Then what you have to do here? You have to apply the formula r equal to whatever formula is there for linear regression coefficient. You have to put the values n equal to 8. Here summation of xy you have to take minus summation of x into summation of y divided by under root of n into summation of x square. From the table only you have to take summation of x square, you have to take summation of y square, you have to take. These values you have to take and put these values, then you have to calculate this one according to whatever formula is there. The value is coming equal to 0.886. Means what? According to whatever R value is there, it is 0.886. Means what? It is relatively strong positive linear association between x and y. This is the prediction. Whatever R value is there, it is 0.886 means what? It is near to 1. Therefore, relatively strong positive linear association between x and y. Such type of whatever data is given, samples are taken. These are suitable for further model building purpose. You can plot here trunk diameter x and tree height also. Depending on whatever the table is given, values are given. You have to put the samples and then you have to draw the straight line. If once you have tested, if that those samples are there, data set is there that is suitable for further analysis, then next step is what? You have to build the linear regression model. Here what you have to do here, population linear regression is there. Whatever data points you have to take, it may be sample linear regression also you can call. For, for linear regression, here y equal to beta 0 plus beta 1 x plus eta is there. Here eta means what? Error rate. Beta 1 is there, that is the slope of this line, straight line. And then beta 0 is there, that is the intercept. Intercept is there from 0 to where that line touches the y-axis. This much distance is nothing but beta 0. This one is graphical relationship. Eta means what? Random error is there for this value, x value. Means what? Whatever eta is there from this one is the line we have plotted. From the line, this much distance, that sample is there, data point is there. That's why this much error. If we neglect this one, eta, then only this much formula we have to use. What is required? Intersect is required. Then slope of the line. How slope of the line is calculated? You have to take 2 points on this one. You have to join. This much portion is there parallel to y-axis, that is delta y. Parallel to x-axis, this distance you have to take, that is delta x is there. Slope can be calculated, that is equal to delta y by delta x. That is the slope, that beta 1. And then beta 0 means what? How much the intersect is there, this much you have to take. According to whatever scale you have taken, according to that one, you have to measure this value, that is the beta 0. Beta 0 is the intercept, beta 1 is the slope, x is the independent variable, y is the dependent variable. Y depends on x. If x value is known, then y can be calculated. If suppose here, for this one, if suppose x is there from this table, x equal to 15 is there. If one's model is built, x equal to 15, y can be calculated. If suppose y is there, that can be taken as 70, then you can calculate x also using this one. Once these values are known, beta 0, beta 1, x value is known, then you can calculate the y value. If y value is known, beta 0 and beta 1 are already calculated based on this graphical representation, then you have to calculate x. Here we are neglecting the eta value. Error value is there, random error we are neglecting. Because these are on the both side, upper side of the line, lower side of the line. This one is y equal to beta 0 plus beta 1 x plus eta is there. Eta is nothing but random error term. The x is their independent variable. Beta 1 is their population slope coefficient. Slope is there. Then beta 0 is the intercept is there. Population y intercept is there. And y is the dependent variable. This much portion beta 0 plus beta 1 x is there. It is linear component. This one is called a linear component. And this one eta is there. This one is the random error component. This is the linear regression model, linear regression equation we can call. This one is actually graphical representation is there for calculating beta 0, beta 1. It is tedious task because every time according to scale you have to draw the data points and then draw the line. You have to take the value of this one beta 0 intercept and slope also you have to calculate. And directly what we are doing here, directly we can use the formula. Here, the formulas for beta 1 and beta 0s we have to calculate. First, you have to calculate beta 1 based on the table. This formula you have to use. Summation of xy minus summation of x into y divided by n divided by summation of x square minus summation of x whole square divided by n. This formula you have to use here. Already from the table the xy values are known. You have to calculate the beta 1. If beta 1 is calculated, then beta 0 you have to calculate. For beta 0, that is equal to y dash minus b1 x dash. The x and y dash is there. These are the mean values. Average values you have to take. Y average value, x average value you have to take. Mean value you have to take. Beta 1 is calculated, then beta 0 can be calculated by taking the average values of this one, y cap and x cap. How y cap and x cap are calculated from this one table? Whatever summation of this one is there, summation of y is there, 321. How many data points are there? 8 data points. 321 divided by 8 you have to take, that is the y cap. Here also 73 divided by 8 you have to take because 8 samples are there. Whatever value is coming, that is nothing but x cap is there, x dash. Like this one, you have to calculate beta 1 and beta 0. If beta 1 and beta 0 are known, then you have to, if x is known, y can be calculated. Y is known, then x can be calculated. This one is nothing but the linear regression model. One more example you have to take here. Sample data for house price prediction. House price, this one in dollars you can take, this one is nothing but y. These house price are given, one particular area, square feet area is given here. Based on this one, apart from these values, if x is there, x equal to 5,000 square feet. For that one, how much amount is required? Y can be calculated. If y is known, this is, you are having this much amount, 5,000 k dollars are there, then how much square feet you want to purchase? The x value. Like this one, for this also you have to extend the table. Xy you have to take, x square, y square, and then summation of x, summation of y, summation of xy, summation of x square, summation of y square you have to take. Then use test it for linear regression. If these data samples are suitable for model building, then you can go for linear regression analysis. First you have to calculate the beta 1, beta 0, then you have to apply the linear regression model. This is all about what we have seen here. Correlation analysis we have seen, discussed correlation to measure the strength of linear association. Simple linear regression model we have seen, y equal to mx plus c. We have solved some numerical problems also based on coefficients for simple linear regression. Thank you very much.